Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P2121 indicates that the accelerator pedal position APP sensor A, also termed as TP sensor D, is reporting an out-of-range condition. This signal is critical as it communicates the position of the accelerator pedal to the powertrain control module PCM. The PCM utilizes this information to adjust fuel delivery, engine performance, and compliance with emission standards. Located within the accelerator pedal assembly, the APP sensor consists of a potentiometer that varies resistance based on pedal position. When the resistance varies beyond defined thresholds, it triggers the P2121 code, indicating a malfunction in the sensor's performance or wiring. Confirming this issue is paramount for ensuring the vehicle operates seamlessly and comprehensively monitoring engine dynamics. The APP sensor A, also known as TP sensor D, plays a vital role in relaying the position of the accelerator pedal to the PCM. This sensor interprets the physical movement of the pedal and transforms it into an electrical signal that is sent to the PCM. The primary function is to ensure the engine's performance aligns with the driver's intended acceleration behavior, allowing for smooth transitions and optimal driving experiences. This component is located in the accelerator pedal assembly, which makes it susceptible to wear, damage, or electrical issues. If the signal falls below 0.32 volts or exceeds 4.91 volts, it indicates a malfunction, prompting the DTC P2121 to register and requiring diagnostic attention. Several factors can contribute to the appearance of DTC P2121. A common cause is the APP sensor itself, which may be malfunctioning due to wear, internal faults, or manufacturing defects. Electrical connections can also play a crucial role. Poor connections or loose terminals can lead to intermittent signals falsely interpreted by the PCM. Additionally, wiring issues such as shorts or opens within the accelerator pedal circuit can create erratic readings. Given that the electronics of a vehicle are complex and sensitive, it is essential to explore these potential causes methodically when troubleshooting this specific DTC. When DTC P2121 is triggered, you may experience several symptoms that indicate a potential problem with the accelerator pedal system. The most notable symptom is often an unresponsive accelerator pedal, which leads to a significant reduction in vehicle performance and ability to accelerate as intended. Drivers may also observe the check engine light illuminating on the dashboard, indicating diagnostic trouble codes have been detected. Additionally, erratic engine performance may manifest, including stalling, hesitation during acceleration, or a decrease in power output, making it crucial to address this error code promptly to ensure optimal vehicle operation. In the first troubleshooting step for DTC P2121, the vehicle should be turned to the on mode. This is crucial as it powers the vehicle's electrical systems, allowing diagnostics to be performed. With the Honda Diagnostic System, HDS, connected, it's necessary to check the APP sensor A to review its current reading against established thresholds. Consider the specific voltage readings. If it is less than 0.32 volts, this indicates a clear failure worth investigating further. A response of yes would prompt the technician to proceed to step 3, validating the failure, while no would indicate that the issue may not be definitive, directing them to step 2 for further inspection. In this second troubleshooting step, the technician again utilizes the HDS to measure the APP sensor A while the vehicle is in the on mode. The measurement is checked to ensure that the voltage does not exceed 4.91 volts. If it does, the technician can confirm a failure related to that specific reading. A yes response signifies that the failure occurred again, guiding the technician to step 8 for deeper analysis. If no, it leads to further investigation into intermittent failures that may indicate loose connections or faulty wiring, emphasizing the importance of checking physical connections for integrity. For the third step in addressing DTC P2121, the vehicle must be turned off, and the APP sensor 6P connector is then disconnected. This specific action allows the technician to isolate the sensor and perform voltage checks without interference from the electrical system. The next task involves measuring the voltage between the specified test points in the APP sensor connector once the vehicle is switched back to the on mode. It is vital to ensure that approximately 5.0 volts is registered as expected. Achieving this reading indicates proper power supply to the sensor, permitting the troubleshooting process to continue towards determining any faults present in the circuit. In the fourth troubleshooting step, a focus on the potential for shorted wires is essential. After turning the vehicle off and verifying the HDS is in SCS short mode for more than 1 minute, the technician disconnects the PCM connector A51P. Conducting a continuity test between specified points allows for precise determination of any short circuits in the wiring. The condition being assessed here should indicate a lack of continuity if the wiring is intact. If continuity is present, it would signify a short in the APS1 wire between the PCM and the APP sensor, requiring immediate attention and repair to ensure the effective operation of the electrical system. The fifth troubleshooting phase is conducted to check for open wires in the APP sensor circuit. The technician begins by connecting the specified terminals with a jumper wire while ensuring the vehicle is powered off. Next, they perform a continuity test designed to detect any breaks in the APS1 wire between the PCM and the APP sensor. A successful outcome should show continuity. If so, it confirms that the wiring is intact. Conversely, if no continuity is detected, it points to an open circuit that necessitates investigating the wire path for potential damage or disconnections that would impair the operation of the sensor. During the sixth step, the technician performs a crucial check of the PCM's internal circuits. After performing the previous steps and ensuring that the jumper wire is appropriately connected, the vehicle is turned on again for a new assessment of APP sensor A's readings. The expectation is to confirm that the voltage reads less than the threshold of 0.32 volts. A successful match would direct the technician to access any authorized service information that may assist in resolving the DTCs or symptoms present. If successful, substituting a known good PCM may indicate a fault with the original unit. If all conditions are met and the errors persist, replacing the APP sensor module becomes necessary for resolution. In this seventh step, checking for potential open wiring in the VCC4 line is conducted following a structured method. The vehicle is switched off and SCS is shorted out for over a minute to establish test conditions. The technician then disconnects the PCM connector A to facilitate an accurate check of the circuitry. Following that, a jumper wire is used to connect specific terminals in the APP sensor 6P connector, allowing for another continuity check that will confirm the integrity of the VCC4 wire running back to the PCM. If continuity is demonstrated successfully, the circuit is confirmed to be good, and the technician can explore further tests or replacements. However, if no continuity can be determined, then immediate action to repair that open wire is essential to rectify the communication issue between the components. In the eighth troubleshooting step, the investigation shifts back to the APP sensor itself to determine its operational integrity. The technician will turn the vehicle to the off position and then disconnect the APP sensor connector to set up for voltage measurements. After switching the vehicle to the on mode, it's critical to measure the voltage at the designated test points. A target reading of around 5.0 volts is expected. Achieving this indicates that the sensor is receiving adequate supply voltage. If this is confirmed, replacing the accelerator pedal module is warranted, as it suggests the sensor itself is defective. If not, follow the protocol to step 9 to check other lines indicating potential issues external to the sensor. In this final troubleshooting step, focus is directed at checking the SG4 line for potential open circuits. Initially, the technician powers down the vehicle and prepares to start the SCS again for proper diagnostic conditions. After disconnecting the PCM connector, a jumper wire is connected to verify the integrity of the SG4 circuit through a continuity test. The expectation should yield continuity readings indicating that the wiring is intact throughout its path. If continuity is confirmed, it underscores the soundness of the SG4 connection, which allows further analysis or PCM substitution as options. However, if no continuity is apparent, the technician must promptly repair any breaks along that line to restore proper function and clear the DTC P2121. After completing all the required repairs for DTC P2121, it is vital to conduct a thorough test drive of the Honda Fit to verify that the repairs were effective and that the vehicle operates correctly. Monitoring behaviors, particularly in throttle response, acceleration smoothness, and check engine light status, provides critical information on the success of the troubleshooting process. After the test drive, reconnect the HDS to scan for any returning DTCs. A successful outcome is indicated when no DTCs reappear, consequently validating that the necessary repairs, whether in wiring or the APP sensor itself, effectively resolved the issue. Proper final verification confirms not just the resolution of the DTC, but reassures the driver of the vehicle's reinstated performance. To avoid recurrence of DTC P2121, it is crucial to incorporate preventive maintenance measures focusing primarily on the vehicle's electrical system. Regular inspections of wiring and connectors associated with the APP sensor ensure that any developing issues can be identified and rectified before they lead to faults. It is particularly important to observe conditions of terminals, ensuring they remain corrosion-free and securely connected. Besides physical inspections, ensuring that all electronic components are updated with any technical service bulletins can improve reliability. Ultimately, proper maintenance reduces the risk of sensor malfunction and ensures smooth operation of the vehicle's electronic throttle control system. In conclusion, resolving DTC P2121 requires a systematic troubleshooting approach focusing on the APP sensor and its associated wiring. Understanding the diagnostic process, identifying component roles, and methodically measuring voltages are fundamental aspects of achieving an accurate diagnosis. The potential for various causes, from the APP sensor itself to wiring issues, emphasizes the need for careful examination of each component in the system. By implementing consistent preventive measures and verifying repairs through diagnostic testing, technicians can ensure the reliable performance of the vehicle. Summarily, thoroughness in both troubleshooting and maintenance is crucial for the long-term reliability of the Honda Fit's electronic throttle control system. Please like and subscribe to the channel. See you next time.